Hey, in this video, we're going to be talking about ocean currents and tides. So this map shows all of the world's ocean currents, right? What an ocean current is, it's a movement of water from one place in the ocean to the other. So generally, when we're talking about ocean currents, we're talking about what are called surface currents, all right? Which is a mass of ocean water that flows from one place to another, all right? So essentially what we're talking about is water that's moving across the surface. All right, water can move up and down within the ocean, but when we're talking about a surface current, we're talking about water that's moving across the surface. All right, there's two types of surface currents. There are warm currents, and these are currents. Warm currents generally move from the warmer areas of the Earth, which are going to be near the equator towards the poles. But then there's also cold currents, and these are going to be currents that move from the poles back towards the equator. So this map right here shows the world's major surface currents. And again, you notice, so warm currents are shown in red here, and the blue lines show the cold currents. And you can see here that in general, the currents that are moving north are the warm currents. All right, so and as you'll see here, this happens because of a density effect. All right, so this combination of warm currents moving towards the north and cold currents moving from the poles back to the equator. And I shouldn't say north or south, because in the southern hemisphere, the warm currents are moving towards the south. All right, and that's because they're heading that's the direction in the southern hemisphere from the equator towards the pole. In this case, it's towards the South Pole. All right, but the combination of this movement towards the warm water towards the poles and the cold water from the poles back to the equator causes a circular motion, which is called a gyre. All right, that's a huge circular moving current system. All right, one other thing about ocean currents is, yes, we understand that the warm currents move north and that the cold currents move south, at least in the northern hemisphere. But what causes this circular movement then? All right, that's caused actually by what's called by the Coriolis effect. All right. Again, the circular motion is caused by the Coriolis effect, and that's a deflection of the currents away from their original course. And it happens because of the rotation of the Earth. All right, so the circular motion that you see here is caused by that rotation of the Earth. In addition to surface currents, there are also vertical currents. And a vertical current is any motion up and down in the ocean. All right. There's two things that can cause vertical currents. One is density. All right. Whenever you have a difference in the density of water, essentially some water is heavier than other parts of water, it can cause water to go up and down in the ocean. But another type of a vertical current or vertical movement of water is called upwelling. And this is when cold water rises from the deep layers to replace warm surface water. And this happens because of wind affecting the movement of water. All right. Upwelling is good because it can bring nutrients to the surface. So this diagram right here shows what would cause upwelling. See how here you can see that a wind is blowing the surface water out to sea. And when this top layer of water gets blown out, something has to replace it. And so what replaces it is water from the bottom. And this water from the bottom, again, it contains a lot of nutrients because there's a lot of dead material at the bottom of the ocean. And it pulls that nutrient-rich water up to the surface, which is good for ocean life. And the last topic that we want to talk about concerning oceans are the tides. All right, tides are the daily changes in the elevation of the ocean. All right, and if you've ever been at the beach and you've been there for a long period during the day, you would notice that at some parts of the day the water level is a little lower, and at some parts of the day the water level is a little higher. All right, and essentially what causes that is the moon. All right, the moon is just like the Earth. It has an ability. It has gravity, and it can pull on things. And so the thing about the Earth is the solid parts of the Earth can't move. All right, so the land below your feet are not going to get pulled upwards by the moon. All right, but the water parts of the Earth can be affected by the moon's gravity. All right, and so in this diagram right here, the moon would be out here to the right. All right, and that's going to pull some of that ocean water in that direction. All right, this diagram right here shows this extremely exaggerated. All right, the amount that the water rises is nowhere near the amount that it shows here. But like on the Earth's surface, it can be between 6 to 10 feet per day. All right, and you would not be able to notice that if you were looking at the Earth from a far away distance. But if you're standing there at the beach, you'll notice it. All right. This picture right here shows what's called low tide, which is where, and this is going to be when the moon is not directly overhead. All right. And you can see all these boats, which normally are floating in the water, are just resting on the bottom of this body of it's basically just sand. All right. And a couple hours from now, the water's going to rush back in, and these boats are going to be floating again. All right. So again, the thing to remember about the tides is that they're caused by the gravitational pull of the moon. All right. And the thing about to remember, and one thing to remember about tides, we know that it's caused by the gravitational pull of the moon. But if the moon is on the right side, you not only have a high tide on the side that's got the moon on it, you have a high tide on the side directly opposite of that as well. All right, low tides are going to be would be like basically where my mouse is right here and on the back side of it. All right, so most places are going to have 2 high tides and 2 low tides each day. All right, and each of the high tides are going to be spread out by 12 hours. All right, and same with the low tides. So the distance in time between a high tide and a following low tide would be 6 hours. So midnight, it would be high. 6 o'clock in the morning, it would be low. Noon, it would be high. And then 6 o'clock at night, it would be low.